Hello everyone and welcome to PostgreSQL Crash Course Day 2. This is your host Mohan. I hope you are doing well and you are enjoying the learning. So my WhatsApp number is +91 is country code and my number is 9021776041. In case if you have still not pinged me, please ping me on WhatsApp so that I can add you in the WhatsApp group. It will be good for your networking as well as few important updates I will share in the group. So with this, let's start our day 2. So as I said, today we will discuss about the page. So what is page? Page is the smallest unit of data storage. It means whatever you are storing in PostgreSQL, it will be stored in a data, it will be stored in a page. It is similar to our SQL Server as well. There also we have a smallest unit as page. Every table and index is stored as an array of pages of the fixed size. So whatever index or table you are storing, it will be stored in a array of pages or sequence of pages, and those pages will be in the form of fixed size. We cannot have variable page size. By default, the PostgreSQL, the page size is 8 KB, so it is similar to SQL Server. We can configure different page size during the compilation of the server. So in last point, whatever I said, the page size is 8 KB. So that this is the default one. If you want to configure the page size, which is more than 8 KB, you can do that in the PostgreSQL. The maximum page size you can set as 32 KB, and that can be done during the compilation of the server, or even if you have installed the server, you can change it by using command called configure. You can give the page size as per your requirement, but the maximum size will be 32 KB. So what can be the need of changing the page size? So the thing is, in some kind of operations or maybe data warehousing operations where we need to fetch the more data per page. So in such kind of operation, we use different size than 8 KB, which is like 16 KB and 32 KB page. All pages are logically equivalent and any row can be stored in any page. So the pages, as I said, like it will be like equivalent pages, and you don't have any control over which row will be stored in which page. So that will be decided by the system itself. So yeah, but the one thing to remember here that a row cannot span multiple pages. A row should be or it can be only in under one page. So in case if you have a row which is having like a size of more than 8 KB, so in that case we use some different terminology or technology or concept here that is called toast in PostgreSQL. We'll see like if I can cover that. But here in PostgreSQL, you can have a row that can be inside one page only. It cannot span multiple pages. So now coming here in PostgreSQL page layout. So as I said, this is a 8 KB pages, 8 KB page, and first component is header. Header will have all the information about the page. It will basically have the information about the free space inside the page. Now, after that, we have a component called item ID. So item ID basically is a pointer to the actual item or a row or a tuple in PostgreSQL. It will have pointer to the actual row. Then we have a free space. So this free space area is just an unallocated space inside a page. Then we have an item, and that item is a row itself or tuple, and after that we have a special component. So one thing to notice here that all the item ID are in the top of the pages, and all the items, I mean the pointers will be in the top of the pages and the rows will be inserted from the bottom to top. So this is the structure of the page. This is special. The special component basically have information about the index access methods. So it is similar like B tree information we have. So it will have information about all its siblings. Okay, so these are the items and descriptions. So page header data, it is 24 bytes long. As I said, it is containing the general information about the page, including the free space. Item ID, it is array of pairs pointing to the actual items. Here item means a row or tuple. It will be 4 bytes per item. Free space, it is an unallocated space. New pointers are allocated from the start of this data, new items from the end. So here, if you remember, in the page layout, we have seen that this item ID pointers will be at the starting of the page, and this item will be at the end of the page. So this is what it is written here, that new item pointers are allocated from the start of this data, and new items, it means new tuples, will be from the end of the free space. Item is actual tuple themselves. Special space, it is an index access methods, specific data, and different methods store different data. Empty is ordinary table. So if there is no index, then in that case, this special space will be empty. So this is what it is written here. Now we are moving to the PostgreSQL architecture fundamentals. So PostgreSQL is a relational database management system with a client-server architecture. So it is similar to our SQL Server, that is also a client-server architecture, where client connects to the server or sends a request to the server, and server responds to the request and fetches the data and give back to the client. So like in our day-to-day life also, whenever we are searching something, whenever we are accessing any website, or if we are logging in somewhere, so we are acting as a client, and the database server which is giving the information back to us, that is the server. So this is how the client server architecture works. So PostgreSQL uses process per user client server model. So in Postgres, a user, when it connects, it will be assigned with a process, and this process will be active until the user disconnects, or maybe until the Postgres restarts. So this is a process per user, one process per user. PostgreSQL has a set of processes and memory structures which constitutes an instance. So whenever you talk about instance, just think about few of the processes and the memory structures. One server can have multiple instances, and those instances do not share their processes and memory structure. Each instance will have their different process and memory structure. So this is very important to understand. Programs run by clients connect to the server instance and request read and write operations. So once you are connected to the PostgreSQL, based on your access, you can request read operations or write operations, whatever you want to do with the PostgreSQL database. And this is also important. The default port of PostgreSQL is 5432. And you know what is the default port of SQL Server? It is 1433. So yeah, this is also a very important point to remember. The default port of PostgreSQL, it is 5432. So now this is a diagram of PostgreSQL process and memory architecture. So uh, once when a client is trying to connect to the PostgreSQL database, so what it will do, it will basically first check the postmaster, and the postmaster will basically check all the information about the authentication, whether it has the correct IP address, whether it has the correct username and password, and it will authenticate the user, and then it will create a new process called Postgres. Apart from this Postgres, it will also initialize all the other utility processes which we will discuss later. So this once this Postgres process is created, it will be assigned shared buffer, that is a memory area, and then now client connects to the database, and it can have multiple operations as per as per their authorization. So just consider a case where we are having a client or a user which is trying to read some data from the PostgreSQL database. So what happens? It will first go to Postmaster, and as I said, this Postmaster will check its IP, its user name, and the password. Once it is validated, this Postgres process will be created, and this Postgres process will be connected with a shared buffer. So in case of read operations, it will check whether the data which is requested is present in the shared buffer or not. If that particular data block is not present here in the shared buffer, it will be fetched from the data files to the shared buffer. That particular data block will be fetched from the data files to the shared buffer, and then the information is sent back to the client. So this completes the whole read operation. And if we already have the data block in the shared buffer, then it will not fetch the data, because it is already present here. So this is all about the read operations. Now consider the write operations, or maybe any update, delete, insert operation. Just consider the update operation. So again, this postmaster will check everything, and then it will create the process Postgres. And again, it will check the shared buffer, that particular data block. If it is not present, it will again fetch from the data files to the shared buffer. And then whatever changes it is making, for example, it is updating a row from salary 10K to 20K. So whatever changes it is doing, it will be written in the wall buffer. So what is wall buffer? You remember the concept in SQL. We have a concept called WAL, that is the write ahead logging, or wall. It means whatever we are writing, that will be written to the log first before it gives the confirmation to the user, or before it is hardened to the disk. So the changes which you are doing, it will not be directly written to the disk. Before that, it will be written to the log. That is called write ahead logging. So the changes which we are doing here will be written in the wall buffer, and this process called wall writer, it will fetch all the wall buffer records from this shared buffer or from wall buffer, and it will write to the wall files. And after that, okay, so yeah, so after that, the confirmation will be given to the clients after the commit that the update has been done. And then whatever updated, whatever data block which is updated, and whatever data which is committed, that will be written to the data files when the check pointer runs the check pointing process. All the dirty records or the committed records will be written from the shared buffer to the data files with the help of a process called writer or BG writer. So this check pointer will create a process, and this check pointer will invoke a process BG writer that will write all those all that data from all the modified pages or the committed records from the shared buffer to the data files. Now we have different components as well. So I will try to cover those components in the next video, because it will take a lot of time to explain everything, and we have a limit of 15 minutes here. So yeah, so just consider one thing, that this wall files are equivalent to SQL Server database log files, and those data files are simply the data files in SQL Server. So that is it for today, and I will cover this PostgreSQL process and memory architecture in detail in tomorrow's video. So please go through all those components which are mentioned here, and you can read about them in detail, and I'll see you tomorrow. Thank you. Take care.